Again, welcome to Jnana Learning. So this is a lecture about one of the applications of Zener diode, that is Zener diode as voltage regulator. So here is a circuit of Zener diode voltage regulator. Okay. So before moving on to the circuit, first we have to know what is a voltage regulation. Actually, it is a measure of a circuit's ability to maintain a constant output voltage even when either input voltage or load current varies. Okay, so that is the voltage regulation. Now, this is a circuit for Zener diode voltage regulator. So here, given the supply voltage, that is VI, that is the input voltage. Now, this is a resistor connected in series with the supply voltage, that is RS. Then we have the Zener diode and a load resistor RL, across which we are getting the output voltage or the regulated voltage. Okay. Now the currents marked down here, that is IS, which is a current flowing through the series resistor, that is this particular resistor, and IZ is a current flowing through the Zener diode, and IL is a current flowing through the load resistor. Okay. Now VR, it is a voltage across the resistor. VZ, it is a Zener voltage, and Vout, which is the output voltage or the regulated voltage. Okay. Now this particular resistor, that is RS, actually it limits the reverse current through diode to a safer value. Okay. Now the supply voltage and RS, they are selected so that the diode operates in breakdown region, and the voltage across the load resistor RL, which is actually the Zener voltage, and the current flowing through the Zener diode, it is called as the Zener current. Okay. Now this particular RS, actually it also absorbs the output voltage fluctuations to maintain voltage across the load a constant value. Okay. Now this particular Zener diode, it is reverse connected across the input voltage, which means that is the cathode is connected to the positive terminal and anode is connected to the negative terminal. Okay, that is a reverse connected across the input voltage whose variations are to be regulated. That is, we suppose that there may be variation in the supply voltage, and that particular voltage have to be regulated by this Zener voltage, and we have to get a regulated output voltage over here. Okay, so that's about the circuit description. Now moving on to the working. So as long as voltage across the load resistor, that is RL, is less than the breakdown voltage, the Zener diode doesn't conduct. Okay. And the resistors RS and RL, it constitute a potential divider across the supply voltage. Okay. Now at an increased supply voltage, the voltage drop across load, that is across load resistor, becomes greater than the Zener breakdown voltage. Okay, that is, at an increased supply voltage, the voltage drop across load resistor becomes greater than the Zener breakdown voltage. Then it operates in its breakdown region. That is, the Zener diode operates in its breakdown region. Now the series resistor RS, this particular resistor, it limits the Zener current, that is Zener current IZ, from exceeding its maximum value. That is, this particular resistor limits the Zener current exceeding its maximum value. Now see, the current IS, that is, which is flowing through the series resistor, it is Vs minus Vz divided by Rs. Vs means the supply voltage or input voltage minus Vz. Vz means the Zener voltage divided by Rs. Rs means the resistor. Okay. And Is is also equal to Iz plus IL. That is, Iz means the Zener current and IL is the load current. Okay. So when the Zener diode operates in its breakdown region, the voltage across it, that is Vz, it remains fairly constant even though the current Iz flowing through it may vary considerably. That is, consider that this particular voltage, that is a supply voltage or input voltage. Vi mean input voltage, we said Vs, that is the same notation, that is for supply voltage. So when the supply voltage or input voltage increases, what happens? The current also increases, that is the current flowing through this increases, and the current flowing through the diode as well as the load resistor also increases. But this particular resistor limits the Zener current to its maximum value. Okay, then what happens is that when the supply voltage increases, the current through both the Zener diode and load resistor increases, and at the same time the Zener diode resistance decreases and the current through the diode increases more than proportionally. Okay, so as a result, a greater voltage drop will occur across the series resistor, that is Rs, this particular resistor Rs, and the output voltage, that is output voltage over here, it will become very close to the original value. Okay, that is a Zener diode can maintain the output voltage within a fraction of volt when the supply or the input voltage may vary over a range of several values. Okay, that is the Zener diode will maintain a constant voltage across the load as long as the supply voltage is more than the Zener voltage. Is it clear? That is, when the supply voltage increases, the current, that is the current Is increases. When the supply voltage or input voltage increases, current Is increases, which means the current through both the Zener diode and load resistor increases. At the same time, what happens? The Zener diode resistance, which decreases, and the current through the diode increases more than proportionally. Okay, it increases, that is the current increases, but we know that for a Zener diode in its breakdown region, even though there is a sharp increase in current through the Zener, the voltage across it remains constant. Okay, that is, that particular voltage drop, the increase in the greater voltage drop will occurs across this particular series resistance, and the voltage across the Zener diode will remain constant. Okay, now the Zener diode can maintain a constant voltage, or we can say that a regulated voltage across it, and we get that particular regulated voltage at the output, that is through the load resistor. Okay, so that's the voltage regulation done by the Zener diode. So this is the working of Zener diode as a voltage regulation. So thanks for watching the video. For watching more videos, please subscribe our channel Jnana Learning.